Welcome back to my channel, everyone. 3 tips here. What I have here is an 18K gold bracelet. It's a men's bracelet. I paid $3,700 for this thing. Notice that it says 750 on the tongue right there. It's too small for me, and Mrs. 3 Tips don't like it. It's too big for her. Let's get a weight on this thing. 98.7 grams of 18K gold. What we're going to do is we're going to refine this thing. We're going to use a little different approach today. People have absolute trust in the value of dollars, and they actually believe that paper dollars are more valuable than gold. And what that does for us, it enables us to buy gold at a steep discount. People's jaws drop open when I tell them how much I can pay them for their gold. Now we're going to look at how to determine the value of our gold. There was 98.7 grams of 18K. 18K is 18 divided by 24. This is 18K divided by pure gold, 24. Equals 0.75. So we multiply our grams times 0.75. So 98.7 times 0.75 equals, we should be looking at 74 grams of pure gold in this bracelet. I just looked up the spot price of gold, and it's $19.60. We divide that by 31.1 grams, because that's how many grams there are in a troy ounce. And we get 1960 divided by 31.1 equals. So we're looking at $63 per gram for gold, pure gold. So now I multiply our 74 grams of pure gold by the price per gram, $63, and that equals, let's see here, 74 times 63 equals, that's $4,662 worth of gold. I paid $3,700 for this bracelet. Many of you will ask, 3 Tips, how in the world did you get the person that was selling this to accept just $3,700? It was actually $3,750. But if there's $4,600 worth of gold here, how did you get them to accept $3,700? And the answer is, people have absolute faith in the value of dollars, and they believe incorrectly that paper money is more valuable than gold. We're going to begin the experiment by adding some hydrochloric acid to a beaker up here on our heating pad, about 300 milliliters or so. I'm going to turn the heat on and start heating up our hydrochloric acid here. In the meantime, what we'll do is take our 18K bracelet here, and I'm going to burn it. Make sure we get any oil or grease that might be on here or any other junk burnt off. Now I had this in the ultrasonic cleaner already, so there shouldn't be a whole bunch of junk on here. But incineration is always a good idea. See that smoke coming off of there? I want to burn it until no more smoke shows up. Notice I'm not quarting with silver like I usually do. This is a total experiment. I don't know how this is going to work, but I'm going to add this straight into the hydrochloric acid now. We've got it heating up in the hydrochloric acid. And so now what I'm going to do is measure out some nitric acid here. I'm going to measure out about 60 milliliters of nitric acid. Let's make it 70. And I'm going to add that right on in. Here we go. This will form aqua regia. And we're going to try to dissolve this bracelet just like it is without inquarting first. I didn't record the time when I started this, but we're probably about an hour and 15 minutes into this process. I'm going to add some hydrochloric acid here to reinvigorate this reaction. I've just added another small beaker full of hydrochloric acid. That's a total of 2 that I've added since we've started. And I'm going to reach down in here and see if I can find our bracelet. There it is. There it is. It's crumbling to pieces. I don't know if you can see that down there. Let me see if I can get a little closer in. There it is down there. It has no effective defense against the aqua regia. It's crumbling to pieces. With the 200 milliliter doses of hydrochloric acid now, I've got about 500 milliliters of hydrochloric acid in there and about 70 milliliters of concentrated nitric acid. So now we're just going to let this boil until all the fume production ceases. And that's when we can fairly safely conclude that all of the nitric acid has been consumed by the reaction. I'm going to reach down here with a little piece of filter paper, get some of our solution on the end of it, and see what kind of reaction we get here with some stannous. Boom. Gold in solution. All right, all the fumes have gone away in here. So now what we're going to do is we're going to pour off this solution into a clean beaker down here. And if you look in there, this is what we've got left. I'm going to put it back up on the heat. And what we'll do is add some hydrochloric acid. Fresh hydrochloric acid going in. That's about half of our material left, maybe a little less. So I'm going to add about 40 milliliters of nitric acid back into the beaker. And we're going to resume this reaction. See if we can get the rest of this to dissolve. The time right now is about past 2 p.m. We've been at this for about 3 hours now. Still got a little bit of gold dissolving in there. And while we're waiting for the gold in here to go into solution, what I'm going to do is add a little bit of ice to this. This is the solution that we poured off. If you notice, it's got a little bit of a green color. That's because we put all of that metal in solution. There's probably going to be a fair amount of silver chloride in here since we didn't in-quart this, and that will probably come out of solution here as we add these pieces of ice. Let's get busy filtering the silver chloride out of this solution here. My guess is that it's going to take quite a while, based on my experience, to get that solution pulled through this filter, because it's going to clog up rapidly with silver chloride. I might be wrong. Here we go. Gold seems to be pulling through fairly quickly, which is a little bit of a surprise to me. There's the silver chloride down in the bottom of our beaker. Not that much. All right, I've got some frozen snow from the freezer here. So what we're going to do is we're going to try to pour off some of the dissolved material in our beaker back here. Pour it right into the frost here. Try to cool it off. We'll get that going through the filter as well. Let's get some hydrochloric acid on the gold. And then I'm going to start pouring in the gold out of here. Got it cooled down. You can see there's quite a bit of silver chloride in our filter here. Let's add a little bit more nitric acid now to our beaker. That's about 20 milliliters. See if we can get the rest of our gold to dissolve now. That pulled through fairly quickly, which is kind of a little bit of a surprise for me. Now what we'll do, get our funnel out of the way, and I'm going to transfer our gold bearing solution here, which don't look too bad, into a beaker and save it, set it aside. What we're going to do now is add a little bit of hydrochloric acid in here. I've been at it now for about, I would say about 5 hours. And as you can see, all we've got is some crumbs down in the bottom. I'm adding small doses of nitric acid now. And trying to get the rest of this gold to go back in solution. I'm trying to keep this filter moist with a little distilled water because I'm going to use it when I get the rest of this to go into solution. I'm going to pour it through this filter, and I don't want it to dry out. I'm not going to spend any more time trying to get this last bit of material to go into solution. What I'm going to do is pour it off into a container of ice here. Cool it down. Try to rinse as much of the dissolved gold out as we can. We're getting a bunch of silver chloride coming over with it. Let me see, let me get this out of the way. I'm going to put the rest of this metal that's undissolved in here into a filter. I'm transferring this material down into a little melt dish here. Alright, let's take our melt dish with these solids in it and put it over here on the melt table and start a melt. Here's our little button of metal. I'll set this aside and we'll take a look at it in a little bit and try to figure out what we got there. In the meantime, I'm going to pour the rest of these solutions through this same filter that we used for the first filtering. And the solution's pulling through our filter much better than I expected. Let's get our gold bearing solution out of here now. I'm going to add it to our main solution here. Don't look half bad actually. Got most of the silver chloride out of here. Alright, we should have about 2.5 ounces of gold in here. I'm going to add a spoon of sodium metabisulfite. Let's see what happens here. That looks good. Let me add another spoon. Wait and see what happens here. This is actually looking pretty good. I'm going to add another spoon of SMB. We already got a white head of foam on top of our solution here. I'm going to reach in here and do a Stannis test right quick. See exactly what we've got in solution left. I should give it a stir first. Stannis test is negative, so all our gold has precipitated out now. Alright, let's put this up on the heat now. We've had the solution on boiling now for about 20 minutes or so. And everything is settled out on the bottom here. I'm going to take this thing now and carefully pour it off into our gold refining waste container. And wow, here's our gold. It's looking fairly spectacular. I'm giving it a few rinses with some distilled water here to get all that green liquid off of there. But I gotta be honest with you, this is looking pretty good, man. I didn't think it was gonna come out looking this good. I just hope the yield is gonna be right for what we were expecting. Alright, let's give it a little rinse with some hydrochloric acid. Alright, here's what our gold looks like in there. Not bad at all. Okay, we've got just about all the color rinsed off of it now. Took about 15 minutes. Now we're going to pour this off into our waste container here. Man, look at that. It looks really good. I'm going to add some hydrochloric acid. Put it back up here on the heat. I'm going to pour in about 30 milliliters of nitric acid now. Nitric acid. We're going to add this right on in and redissolve this gold a second time. While we're at it, let's shoot in a little bit of sulfuric acid to take care of any lead that may be present. Still got a fairly decent amount of gold that needs to go into solution. So what I'm going to do here is add a little bit more hydrochloric acid to this beaker. And then we're going to add a squirt of nitric acid right on in there. And then what we'll do is we'll take this and we'll pour it right on into our our beaker here. See if we get the rest of this gold to dissolve. Everything is dissolved. I'm going to pull this down off the heat and let it cool off. I'm going to add some ice to help this thing cool off a little bit. We've allowed the solution to cool off. And now what we'll do is filter it out. Shouldn't be much in here now on this second refining. Let's see what we got here. There's still a little bit of junk in our gold solution, as you can see by that filter. That's okay. Let's get this into a clean beaker now. It gets set up to precipitate out our pure gold. Now we're going to add some SMB and do a second precipitation. Here we go. I think that'll do it. I'm going to put this up on some heat now and boil it real good so we can get this gold to settle out quickly. Well, this is looking very, very promising. What we're going to do now is pour off the waste into our temporary waste container here. Let me get this thing lined up. Couple of rinses with hydrochloric acid. Let's take this over to the melt table now. We're going to melt this up a nice pure gold bar. Here we go. Here's our pure gold bar, looking fantastic. Let's see what we got for a weight on this thing. We were expecting 74 grams, 72.8. That's pretty close. And we used a highly unusual process this time. We skipped the inquartation. We did a double refining and we got us a nice piece of pure gold. We also got this little silver button. Let's see what we got on weight on that thing. It's about 3.5 grams of silver. What I'll do is I'll just throw that into my silver jar or silver stash and use it for the inquartation in a future video. All right. This is the man of the hour right here. This pure gold bar is just beautiful. This will conclude the video. Thank you for watching.